Let's continue with the systemic circuit, which supplies oxygenated blood to all non-pulmonary tissues. So oxygenated blood leaves the left ventricle through the aorta, and deoxygenated blood returns to the right atrium through the superior and inferior vena cava and coronary sinus. The systemic circuit contains about 84% of the total blood volume at any one time. So we'll start our tour of the systemic circuit with the arteries, which are pictured here. The ascending aorta is the first systemic vessel, which begins at the aortic semilunar valve. The left and the right coronary arteries, not pictured here, are branched off near the base of the aorta. The aortic arch then curves across the top of the heart and becomes the descending aorta, which drops down through the mediastinum. Let's take a look at some of the arteries which then come off of the aortic arch, like the brachiocephalic trunk, which branches to form the right common carotid and the right subclavian artery. We also have the left common carotid and the left subclavian coming off of the aortic arch. So this is an example of non-mirror image arrangement. From here on, the arteries are the same on both sides of the body, so designation of right and left is not necessary. Next, let's look at the arteries that supply the arms, chest wall, shoulders, back, and central nervous system. Starting with the internal thoracic artery, which supplies the pericardium and anterior wall of the chest. The vertebral artery supplies the brain and spinal cord. The thyrocervical trunk supplies the pericardium, chest, neck, shoulder, and central nervous system. And after passing the first rib, the subclavian gets a new name, the axillary artery. This artery crosses the armpit and becomes the brachial artery, which provides blood to the radial and ulnar arteries. And at the palm, they form anastomoses of the palmar arches and branch into the digital arteries. The carotid arteries and its branches supply the brain and the face. Let's take a look at those next. The common carotids ascend up into the neck and divides into the external carotid artery and the internal carotid artery. The external carotid artery supplies the pharynx, esophagus, larynx, and face. The internal carotid artery enters the skull and supplies the brain and eyes. In addition to the internal carotid artery, the brain also receives blood from the vertebral arteries. In the cranium, the left and right vertebral arteries enter the skull and they fuse to form one basilar artery. And this is another view to show how the left and right vertebral arteries enter the skull and fuse to form that basilar artery. The basilar artery then gives rise to the posterior cerebral and posterior communicating arteries, which tie into the internal carotid. And with its branches form the cerebral arterial circle, or the circle of Willis, which is a ring-shaped anastomoses, which reduces the likelihood of an interruption of blood supply to the brain. Let's look more inferiorly now at the major arteries of the trunk. The descending aorta is continuous with the aortic arch. The diaphragm divides the descending aorta into the superior thoracic aorta and an inferior abdominal aorta. The thoracic aorta supplies the internal intercostal arteries carrying blood to the vertebral column and the body wall, as well as the lung tissue, though it's not involved in gas exchange, the esophagus, pericardium, and other structures. The diaphragm is supplied by both the superior and inferior phrenic arteries. The abdominal aorta delivers blood to all the abdominal pelvic organs and structures. The celiac trunk branches into the left gastric, splenic, and common hepatic arteries to supply the stomach, spleen, pancreas, liver, gallbladder, and duodenum. The superior mesenteric and inferior mesenteric supply the small and large intestines. The adrenal and renal arteries are paired vessels, meaning there's a left and a right, though only the right side is labeled in this picture. They arise laterally from the abdominal aorta and they travel behind the peritoneal lining to reach the adrenal glands and the kidney. Another set of paired arteries are the gonadal arteries. They originate between the superior and inferior mesenteric arteries. In males, they're named the testicular arteries, and in females, they're named the ovarian arteries. Just superior to the terminal segment of the aorta, a pair of lumbar arteries branch off and supply the spinal cord and abdominal wall. Inferior to the lumbar arteries, the aorta then splits into the common iliac arteries to carry blood to the pelvis as the internal iliac arteries and to the lower limbs as the external iliac arteries. Once in the thigh, the external iliac artery branches, forming the femoral and the deep femoral artery. When it reaches the back of the knee, the femoral artery becomes the popliteal artery, which branches to form the anterior tibial and the posterior tibial and the fibular arteries. At the ankle, the anterior tibial artery becomes the dorsal pedis artery, and the posterior tibial artery divides into two. These three arteries are connected by two anastomoses to produce a dorsal arch and a plantar arch. Blood from each of the body's tissues and organs returns to the heart by means of a venous network that drains into the right atrium through the superior and inferior venous systems. Complementary arteries and veins often run side by side and have comparable names. One major difference between the arterial and venous systems is the distribution of the arteries deep in the neck and the limbs, whereas the venous tend to have two sets of peripheral veins and one superficial and one deep. So we'll start with the superior vena cava, which drains the head and neck, upper limbs, shoulders, and chest. Here's another view of the superior vena cava. Small veins in the neural tissue of the brain empty into a network of thin-walled channels called the dural sinuses. The largest of the dural sinuses is the sagittal sinus. These are drained by the internal jugular veins. The more superficial external jugular vein collect blood from the superficial structures of the head and the neck, like the temporal, maxillary, and facial veins. The vertebral veins drain the cervical spinal cord and the posterior surface of the skull. Next, we'll explore the venous return from the upper limbs and the chest. Digital veins drain into the venous network in the palms called the palmar venous arches, which then drain into the cephalic vein and the basilic vein. The median cuboidal connects the cephalic and the basal veins. Deeper forearm veins are the radial veins and the ulnar veins, which fuse to form the brachial vein, which joins the basilic vein and becomes the axillary vein at the armpit. The cephalic drains into the axillary vein, and the axillary continues and becomes the subclavian vein at the first rib. The subclavian vein merges with the internal and external jugular veins to create the large brachiocephalic vein. The left and right brachiocephalic veins combine into the superior vena cava. The azygos vein drains the chest wall and joins the superior vena cava before it enters the right atrium of the heart. The inferior vena cava collects most of the venous blood from organs inferior to the diaphragm. So we'll start distally again and move as the blood does in the venous system. So down at the toes, the blood collects into a network of plantar veins, which drain the plantar venous arch, which drains into the deep veins of the leg, the anterior tibial vein, posterior tibial vein, and fibular vein. The dorsal venous arch drains the superior surface of the foot and collects into the superficial veins of the great saphenous and the small saphenous veins. The small saphenous tibial and fibular veins unite to form the popliteal vein behind the knee. The great saphenous and deep femoral veins join the femoral vein to become the external iliac vein. The external iliac is joined by the internal iliac vein, which drains the pelvic organs, to become the common iliac vein. When the right and left common iliac veins merge into the inferior vena cava. And like the aorta, the inferior vena cava lies posterior to the abdominal pelvic wall, and as it ascends towards the heart, it collects blood from the lumbar veins, the gonadal veins, the renal and adrenal veins, the phrenic vein, and the hepatic veins. Last, we have the hepatic portal system. So blood going through capillaries of the digestive organs absorb nutrients, but they also absorb some waste, some toxins, and this blood has to be processed by the liver before it can enter the general circulation. So capillaries from the lower large intestine are drained by the inferior mesenteric vein. Capillaries from the stomach, spleen, and pancreas join at the splenic vein. Sorry, clicked too soon on that one. Capillaries from the small intestines and from the large intestines merge into the superior mesenteric vein. In all three, the splenic, superior, and inferior mesenteric join to become the hepatic portal vein. So blood from these veins are going to enter the liver capillaries, and from there, also the gastric veins and the cystic veins are going to join the hepatic portal vein, and that blood will then enter the capillaries in the liver and be drained by the hepatic veins, where they will then be drained into the inferior vena cava. So that is the hepatic portal system and concludes the systemic circuit. So take a moment, pause the recording, and see if you can answer these 3 questions about section 13-7 before you move on to the next section. Section 13-8 looks at some changes that happen at birth. You see, the fetal and adult cardiovascular systems have many differences because of their different sources of respiratory and nutritional support. Embryonic lungs aren't functional, and the digestive tract really doesn't have anything to digest yet. So all of the nutritional and respiratory needs are met for the fetus by the placenta. And this is where maternal and fetal circulatory systems are in close contact and diffusion can occur. You see, low oxygen fetal blood flows through the umbilical arteries, and at the placenta, carbon dioxide and waste cross to the mother, oxygen diffuses into the fetal blood. And that blood returns to fetal circulation through the umbilical vein. Some blood goes to the liver, the rest goes to the inferior vena cava through the ductus venosus. Notice the foramen ovale is labeled in this picture, and this is, if you'll recall, an interatrial opening in the fetal heart, and there's a flap that acts as a one-way valve from the right to the left atrium. And this allows blood to bypass the pulmonary circuit because, again, the fetus isn't using its lungs yet. The ductus arteriosus is also labeled here. This is a short vessel that takes most of the blood from the right ventricle directly to the aortic arch of the systemic circuit. And at birth, when the infant takes its first breath, the pulmonary vessels are going to expand. The ductus arteriosus is going to contract. Blood will start to flow into the pulmonary trunk, and the remnants convert to the ligamentum arteriosum, and the flap across the foramen ovale is going to close, and what you'll have is that residual indentation, which in the adult heart is the fossa ovalis. And that concludes the lecture on chapter 13.